Okay, hey, my name is Morgan. This is for physical science lab for Kathryn Burns at Arkansas State University. So, here comes my dog, sorry. Okay, so hey, get down. Sorry. Okay, the first thing we're going to do, I guess, is just show you that I have a Snickers and a Milky Way. Okay, and then we're supposed to measure the length, width, and height in centimeters. So I'm just going to take the wrapper off of these, turn it down so you can kind of see it. This is the Snickers. I don't know how to make that where there we go. Okay. So, just a centimeter side. The length would be this, I believe. So that's like 2.5 centimeters. And then the width is almost 1.5. Probably closer to 1 without that little knot, so I'm just going to put 1, sorry. And then the height would be a little over 9. Yeah, more like 9.5. Okay, so that is the Snickers. Here's the Milky Way. Okay. So, the length of this one would be 2.5 again. The width is like 1 again. And then the height would be like 8.5. So I guess this one's smaller. Okay, so then next we wanted to get the mass in grams. So the Snickers says that it's 52.7 grams. And I get it, here's my little scale. The one it's turned on. I get it to be 55. Or, yeah, 55 grams. So it's a little off. Okay. And then with the Milky Way, I get it to be 52.2 grams. And on the scale, it's 52. So that one's closer. Okay, so the next we needed to calculate density, which is mass over volume. So the volume for the Snickers would be 5 times 1 times 9.5, which would be 2375 over the mass, which is 55. Which comes out as a density of 2.37. 2. Okay. And then so for the Milky Way, it would be 2.5 times 1 times 8.5 for a volume of 21.25. And then with the 52 for the mass, your density would equal 2.45 or 45 rounded. Okay, so next we're supposed to cut the chocolate in half. So this is the Snickers. I think that's even. There's that one. And then here's the Milky Way. There we go. Alright, so here's 1 and 2, and here's 3 and 4. So the length, width, and height of each individual one. So piece 1 would be that's an inch, I'm sorry. Would be like 2.5, right? I guess they're all going to be that, since that didn't really change. So I'm just going to go ahead and write 2.5 for all of them. And the width didn't really change either, since we didn't cut that. We only messed with the height, really, so I'm just going to go ahead and put 1 since we already measured that. And then as far as the height, this one is 4.5, so for the first piece I'm going to put 4.5. And this one is about 4.5 too, so I don't know how I got those so close. Okay, and then for piece 3 and 4, for 4 I got 4 centimeters, for piece 3 I got 4 centimeters, and then for piece 4, I got 4 centimeters as well, roughly. Might be a little bit over. Okay. And then the mass of piece 1, 2, 3, and 4. Okay. So for piece 1, I get 29 grams. For piece 2, I get 26 grams. For piece 3, I get 26 grams. And for piece 4, I get 26 grams. So I guess I cut the first piece a little different. Alright, and then the next step was to get the density of all those. So the mass of the first one would have been 29 divided by what the volume was, which would be 2.5 times 1 times 4.5, which would be 11.25. So 29 divided by 11.25 is 2.57 repeating, so I'm just going to make that 5.6 as the final answer. And for piece number 2, the measurements are pretty much the same, so you would get the 26 as your mass and 11.25 as your your volume, And then the density would be 2.31 repeating. For problem 3, or piece 3, the height, or the length was 2.5, width was 1 centimeter, and then the height was 4 centimeters, which would equal a volume of 10 over 26 is the mass, and which would leave a density as 2.6. And then for piece 4, the measurements were the same and the mass is the same, so you would also get a density of 2.6 for piece 4. Alright, well, that's it. Hope you have a great week.